Good morning, I am Dr. Senthil Kumar from the Department of Agricultural Engineering, SNS College of Technology. Let me present a topic of gaseous fuels, which is in the course of heat power engineering for the fifth semester agricultural engineering. Case of gaseous fuel, in this video, let us discuss about the CNG, that is compressed natural gas, LNG, that is liquefied natural gas, then the producer gas as well as the water gas. We will see about the nature as well as the manufacturing method of these various gaseous fuels. To say about this compressed natural gas, which we used to term as CNG, it is obtained from the well ducts of oil bearing regions. When natural gas occurs with the petroleum oil wells, it is called as wet gas, and it is having more amount of moisture. The wet gas is then suitably treated to remove the propane, butane as well as butane, which is used as LPG. When the natural gas is compressed, we used to term it as the CNG or the compressed natural gas. This can be either be stored in tanks of vehicles as a compressed natural gas at 3000 to 3000 psi, or as liquefied natural gas of pressure 20 to 150 psi. A suitably designed natural gas engine may have a higher output compared with the petrol engine, as the octane number of the CNG is more than that of petrol. But the thing is that the storage, cooling as well as storage is being difficult. CNG is often confused with LNG, that is liquefied natural gas, while both are stored from the form of natural gas. The main difference between the CNG, it is in the compressed form, while LNG is in the liquefied form. CNG has low cost of production and store compared with the liquefied natural gas. This does not very expensive cooling methods as well as cryogenic tanks as in case of LNG. CNG requires a much larger volume to store the same mass of the natural gas and use of very different pressures. To safety properties of the CNG, it is cheapest, cleanest and least environmental impact alternative fuel. Vehicles powered by CNG produces less carbon monoxide and hydrocarbon. It is less expensive than petrol and diesel. The ignition temperature of CNG is about 550 degrees Celsius. It requires more air for ignition. Next, we will discuss of the producer gas. This producer gas is the mixture of combustible gases like carbon monoxide, hydrogen with a large amount of non-combustible gases like nitrogen as well as the carbon dioxide. Its calorific value is 1300 kilocalories per meter cube. It is prepared by passing air mixed with a little steam over a red hot coke maintained at a temperature of 1100 degrees Celsius in a special reactor called gas producer. It consists of a steel vessel of 3 meter in diameter as well as 4 feet meter in height. Inside is lined with refractory bricks. It is provided with cup and cone feeder for the purpose of continuous supply of this coke to the reactor. There will be a side opening for taking the produced gas outside. At the bottom, it has inlets for passing air as well as steam. Here, in case of this producer gas, air and steam will be allowed inside mixing. So this diagram shows the reactor setup for the manufacture of producer gas. You can see in the top there is a provision for feeding the coke. Similarly, in the bottom there is a provision for supply of input, that is the air as well as the steam combination. And there are three regions are there. One is the combustible zone, one is reduction zone as well as the distillation zone. So what is happening, the coke is maintained as a high temperature of 1100 degrees Celsius inside the reactor, and the air along with the steam is made to pass to this red hot coke. So reactions are taking place in all these three regions of combusting zone, reduction zone as well as the distillation zone. And in the right side you can see at the top there is the provision for taking the producer gas outside, as well as at the bottom there is a provision for removing the ash produced during the reaction. So various reactions that is taking place. The bottom zone is the ash zone. This is the lowest zone consisting mostly of ash. The incoming air as well as steam will be preheated by means of this hot ash. Next is zone, that is the combustion or oxidation zone, where the reaction that is taking place over here is the exothermic reaction. Exothermic means we know that heat is liberated outside. So that C plus O2 gives CO, similarly C plus half O2 gives CO2. So amount of heat like 95 kilocalories as well as 29 kilocalories of heat is liberated during this zone. And next zone is the reduction zone. Here the reaction taking place is the endothermic reaction, in which Heat will be absorbed during the reaction, that is C plus CO2 gives 2CO, similarly C plus H2O gives CO plus H2, and the endothermic reaction in which heat is taken inside, that's why it is given as negative symbol minus 36 kilocalories as well as minus 29 kilocalories, and the last zone is the distillation or drying zone. In this zone, the 400 to 800 degrees Celsius of temperature is maintained. The downcoming coal is heated by the outgoing gases. The gas given by the heat given by the gases and heat coming out from the reduction zone will distill the fuel. The fuel that we are producing over here is the producer gas. It is used as a uses of this producer gas. It is used as a reducing agent in metallurgical operations. It is also used for heating the muffled furnace, open heart furnace, etc. Next gaseous fuel that we are going to discuss is the water gas. Here it is similar to producer gas. Only thing is that there the inlet is air and steam in the same line, while in case of this production of this water gas, inlet of air is on the left side, similarly inlet of steam is on the right side, and the air as well as the steam will be allowed alternate fashion. It is a mixture, water gas is a mixture of combustible gases like carbon monoxide, hydrogen, with a small amount of non-combustible gases like carbon dioxide, nitrogen. Its calorific value is around 2800. And the manufacturing step is given. The water gas produced consists of a tall vessel lined inside with refractory bricks. It is provided with a cup and cone feeder at the top, a side opening for water gas exit. At the bottom, it is provided with two inlet pipes passing air and steam. When the steam and air, little air is passed alternatively over a red hot coke maintained at a temperature of 900 to 1000, where in case of producer gas, the coke is maintained at a temperature of 1100 degrees Celsius. Water gas is produced. This diagram shows the manufacture of water gas. Here you can see in the left side, there is a provision for steam supply. On the right side, there is a provision for air supply, and in the bottom there is a provision for removing the ash that is produced, and in the right top of the right side there is a provision for taking the produced gas, that is water gas, outside. So manufacturing methods, how it is created, the step is given one by one. The reaction that is taking place, very first step, steam is passed to the red hot coke where CO and H2 gases are produced. The reaction is endothermic. Endothermic means we know very well. Heat is taken inside. Absorption of heat takes place. Hence the temperature of the coke bed falls. So C plus H2O gives CO plus H2. Endothermic reaction where minus 29 kilocalories of heat will be taken for this reaction. In this second step, in order to raise the temperature of the coke bed to 1000 degrees Celsius, the steam supply is temporarily cut off and the air is now blown in. The reaction is the exothermic reaction, that is C plus O2 gives CO2 and 2C plus O2 gives 2CO. It is an exothermic reaction in which heat will be liberated. Thereby the temperature will be of the red hot coke will be increased. So by means of alternately supplying the air and steam, the temperature of the coke bed will be maintained. Where the uses of the water gas, it is used for production of H2 in the synthesis of ammonia. It is also used as a source for illuminating gas as well as the fuel gas. Thank you for watching this video. Thank you once again.